Hey, welcome back. We are in the second leg of our Thinking and Intelligence chapter, and we're going to take a look at problem solving and decision making. So I want you to think about your decision about where to attend university after you graduate from TCC. In class, I like for people to find someone and talk to them about all the factors involved in how they're making that decision, and then try to identify the process. I thought about making it a discussion board, but I'm going to do something else for that. So I would say to you tonight, why don't you go find someone to talk to about this? We're currently doing this with my son. He is a senior in high school, and we've been thinking about college since he was born, saving for college since he was born, and we've been visiting colleges since he was a sophomore. So what was our process like? Well, we definitely looked at Texas schools first, but then we also expanded to Oklahoma, Arizona, and Louisiana. And then we also considered some far-flung places. So he considered MIT, for example, and he also considered Penn. I didn't really want him to go that far. I want him to go far enough away that honestly, I want him to go far enough away that he can't come home on the weekend all the time. But Massachusetts is a little far for my taste. So location was definitely one of the first ones. Second one is probably something like, do they have the program? So he was interested in TCU, Texas Christian, but they don't have an electrical engineering degree, so that's out. Let's see, prestige. How prestigious is it? What's the graduation rate? How much money does the typical graduate earn? We also thought about size. I personally like the idea of a bigger school. I like the idea of Texas A&M because it's enormous and you know that there's so much available. But some people prefer and would really do better in a small environment. Culture is another big one. I don't think that our son is thinking about that a whole lot, but his father and I are definitely thinking about the culture of the university. So I hope you guys have been thinking about some of those things. We created a spreadsheet to kind of think through all of these factors. If anybody wants to see an example of that, just shoot me an email and I'd be happy to share. Somebody shared their spreadsheet with me a couple years ago. So let's think about some definitions of our two key ideas here. That's decision making and problem solving. So decision making is when we attempt to select the best alternative among several options. So this guy has a decision to make. He can go here where it's sunny, and he can go there where it's dark. Where would you go? I have to say, if I were with other people that I felt safe with, I would definitely go here. If I were by myself, totally go here. Anyway, this is attempting to decide which is the best thing to do. So which college is best to go to, what clothing to wear, should you take an umbrella or not, what color to paint your walls. These are decisions. Who to date, who to ask to marry you, what to have for dinner. These are decisions. What kind of deodorant to buy when you go to the store. Problem solving is different from decision making. When we solve a problem, we're trying to find a way around an obstacle in order to reach a goal. So, for example, I've been doing quadratic equations with my 14-year-old daughter. That is definitely problem solving. We're trying to get to solving X, and there's a basic approach to it, but we sometimes end up going different ways. Let's see, the internet went out at our house on Saturday, and so there were a number of things we could do. We could reset, we could wait, we could call the provider, we could unplug and plug back in the router. There's different things that we can do. So let's think a little bit more about some problem-solving strategies, and hopefully that'll help you to think about how you should be going about your daily life. So one thing that we can do when we're trying to solve a problem is engage in trial and error. This is where we try a variety of solutions and eliminate those that don't work. Let's think about this, for example. Let's think about your parents have put a password on the Netflix account to prevent you from seeing mature content, and you want to figure out what the password is. Okay. Now, would trial and error be a good idea or a good strategy? You could try a variety of solutions, so you just try random things. randomly try BIM 234, and then randomly try PSSTE. I don't know. Randomly trying things and eliminating things that don't work. Now you compare this also with a heuristic. Okay, we'll talk about that. In fact, let's go ahead and talk about that one next. A heuristic is a general rule of thumb to reduce the number of possible solutions. So if you're trying to figure out the password, you might try someone's birthday rather than trying random combinations of numbers. So rather than trying to guess 5693, you guess 0308 because that's their birthday. Their birthday was March 8th, something like that. Another kind of heuristic might be something like, what is the previous password that you knew? What's your street address? What's their name? What's their name backwards? Who knows? There's all kinds of heuristics people might use. An algorithm is a specific rule, procedure, or method that will always produce the correct solution. So, for example, degrees Celsius to Fahrenheit is Celsius times 9/5 plus 32, and that will always get you the right answer. You could guess all day long how many degrees 22 is in Celsius in Fahrenheit, and you probably would take a long time to get there. You could do a heuristic, but the best way to get something like that is definitely going to be an algorithm. So an algorithm, if you're trying to figure out your parents' password to Netflix, would be something like start to go through all the possible combinations. So say it's a 4-digit number, 000000010002, and so on, until you finally get the right combination. Now you can see that this is going to work really well for something like this, but it's not going to work well for the password. Probably heuristics is going to work the best for your password problem. All right, so let's think about some problem solving. So I've got a couple of problems for you, and I want you to try to figure this out. So problem number 1, 6 drinking glasses are all lined up in a row. The first 3 are full of water, and the last 3 are empty. By handling and moving only one glass, change the arrangement so that no full glass is next to another full one, and no empty glass is next to another empty one. So the first 3 have water, the last 3 are empty. You can only handle and move one. All right, I'll give you a minute to think about that. So hopefully you've paused the video and thought about that a little bit. Let me give you one other problem. A man who lived in a small town married 20 different women in that same town. All of them are still living, and he never divorced any of them, yet he broke no laws. How could he do this? So go ahead and pause for a second, pause your video, and think about this. Go find your brother or your girlfriend or your mom and see if you guys can figure that out. These are problems that we have to try to solve. All right, so hopefully you've done that. And let's take I don't have the answers, but I do have the answers. The answer to the drinking glass is that you pick up the second glass and then you pour it into the 5th glass. Okay, so you pick up the second glass and pour that water into the 5th glass and then set the glass back down. That's the solution. The solution to problem number 2 is that the man didn't become married to them himself. He was a minister or a judge, and he performed the marriage ceremony. He married them to other men. So that's the solution. And so if you're thinking, oh man, I didn't think about that. I should have thought about it. Don't worry, you're in good company. What got you a little bit stuck from thinking up the right answer is something called functional fixedness, where we think to ourselves, oh, I have to move the glass. And you can't just move it. The only solution here is to pour it. The functional fixedness here is that we tend to think of he married them, meaning that he got married to them himself, and we're kind of stuck in thinking that way, and we don't think a little bit more flexibly. But if you did get it, in fact, if you did get it, probably you experienced it as a sudden flash of insight. A sudden flash of insight refers to understanding or solution that occurs in a sudden stroke of clarity, that feeling of aha. In a classic study, Wolfgang Kohler provided chimpanzees with some out of reach bananas up here and materials that could potentially be used to fetch them. So these were down on the ground. They figured out I can stack these and stand on them in order to reach the bananas. Now, they did not seem to use trial and error. They didn't try a bunch of different things. They seemed to rely on a sudden flash of insight, and that's probably what you experienced if you got this correct. So let me give you a couple of other problems. You don't have a toilet paper holder in your house. Look around. What else could you use? And the second one is you don't have anything in which to plant your new flowers. Look around and see what you could use. So pause the video and just give that a little bit of thought and see what you can come up with. So did you come up with anything like this for the toilet paper holder? Maybe this is the handle of a paint roller, or tires, or a bucket. Bucket's probably not as good as the tires because it would need to be a little bit open on the bottom. So who knew that a paint roller could be used for holding toilet paper and that car tires could double as planters? Sometimes though, if you didn't come up with anything at all, or you certainly didn't come up with anything like this, it's probably because we have a hard time imagining using objects for very unconventional purposes. We tend to be resistant toward using familiar objects in new ways. That's called functional fixedness, and it can really get in the way of problem solving. Sometimes we have a mental set where we tend to persist in solving problems with solutions that have worked in the past. So try to think outside the box. So I'm going to give you two more problems. So here's the first one. You've been given a box of matchsticks, 2 candles, and some thumbtacks. And your job is to create out of this stuff a candle holder that will hold the candles upright and they won't fall over. Okay. The second problem is this one. You need to take each of these 3 equations and make them valid. Make them actually work. Because 3 plus 3 equals 3 is not correct, right? 1 minus 3 equals 2 is not correct. So I want you to try to figure out how you can solve these problems. Try to get around your mental set and your functional fixedness. Try to think about using these materials in creative ways. I'm going to pause the video and I want you guys to think about them. Hey guys, welcome back. Did you solve the problems? So I'm here to give you some solutions. I hope you did it. We do have a lot of fun in class when we do this. So here's a potential solution. Certainly there could be others. You can take the box apart and use the thumbtacks to attach it to the wall, burn a little bit of the wax and let some of that wax melt right here, and then it will stay in place. Clever. All right, did you figure this one out? All right, here we go. So the functional fixedness that we engage in here is that we don't think about taking the box apart. The functional fixedness we engage in with this one is that we tend to think that we should be moving the numbers rather than the operators. But it's by moving matchsticks in the operators that will actually solve it. So instead of 3 plus 3 equals 3, we move this one to make it equals, and now we have 3 equals 3 equals 3. On this one, we can move one of these over here, and now we have 1 equals 3 minus 2. And here, we can move one of these over here, and now we have 4 minus 3 equals 1. All right, so the functional fixedness is that we tend not to think about moving these, we tend to think about moving those. All right. Oh, There we go. So that is a quick little bit on problem solving and decision making. What I would like for you to take from this one is decision making and problem solving, those basic definitions. And then I want you to be aware of trial and error, algorithms, and heuristics. Be aware of, boy, my thing is going so slow. Be aware of insight, functional fixedness, mental set, and there we go. All right, I'll see you in the next video. This is a short chapter, guys. Our next video is a little bit longer. We're going to do a little bit on intelligence. I'll see you then. Thanks.